Transformations and parent functions, section 2.6. Similar graphs to a parent function. If you are a parent function, you are the most basic. So we're going to take a look at these 6. We're going to focus on absolute value and square root. We'll work with those. We already worked quite a bit with linear functions. We have chapters that these 3 come up in. But let's talk about all of them just so we know what we're talking about here. The most basic function for a linear parent function for y equals mx plus b has a slope of 1 and a y-intercept of 0. That gives you the the y-intercept is 0. That gives you the graph y equals x. Domain would be negative infinity to infinity. Range also negative infinity to infinity. All real numbers. Absolute value, if you made a xy table and put in some negatives and some positives, you're going to get 3, 2, 1, 0, 1, 2, 3. Remember, the absolute value of negative 3 is 3. So what we kind of have here is we kind of have the linear function, but all those negative y values are reflected up over the x-axis. So we get this v. So we kind of think about it as, this can be thought of as a piecewise function where we have part of the graph is y equals x and part of the graph is y equals negative x. But we're going to kind of graph it as a v with a slope of 1 this way, slope of negative 1 this way. Then we'll make some adjustments. The domain is, again, all real numbers. The range is would be 0 to infinity because we don't go down into the negatives. Square root, if I was going to make a table of a square root, we've got 0, 1, 2, 3, 4. Square root of 0 is 0. Notice my domain here, I don't go negative because I can't take the square root of negative. We'll talk about imaginary numbers down the road, but can't take the square root of a negative, so my domain is 0 to infinity, and my range is also 0 to infinity. Some people think that this looks like it's going to level off, but square roots of really big numbers are still really big numbers, so you're still heading towards infinity. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. That's the easiest way to graph it. The square root of 2 and the square root of 3, you get like 1.414, and you get like 1.7 here. So you can see yourself climbing up. But if you do 0, 1, 4, and 9er, you can kind of see what's going to happen there. Quadratic, we're going to have a whole chapter on quadratics. Y equals x squared. So when you have 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1 squared is positive 1, negative 2 squared is positive 4, and so on and so forth. Domain here is negative infinity to infinity. Range here is 0 to infinity. That's my lowest value. Exponential function, we will also work on a chapter with exponential function. The thing about an exponential is we have an asymptote. And the asymptote will never cross over. Think about taking the number 2. If I raise 2 to a positive number, obviously I get big. So this is exponential growth. But if I raise 2 to a negative number, 2 to the negative 1, if x is negative 1, I get 1/2. And 2 to the negative 2 is 1/4. And 2 to the negative 3 is 1/8. And 2 to the negative 4 is 1/16. So as I go out here in negative land, I get closer and closer to 0. So my domain, I can put anything in there for x to be raised to a power. My domain is negative infinity to infinity, but my range, I'll never actually get 0. My range is 0 to infinity, but now I need the parenthesis. Rationals, divide it. You can't divide by 0, so you have this going this way, and you have this going this way. So you've got two asymptotes at y equals 0 and y equals x. And then you think about, you put in the number 1 is right here. 1, 1 is there. Negative 1, negative 1 is there. 1 over 1 is 1. So if you made an xy table, that's what you would get. 1 over 2 is a half. 1 over 3 is a third. So these numbers here, like if I go to a half, 1 divided 1/2, flip the second guy and multiply, and I get 2. So a half is 2, a third is 3, a fourth is 4. So we're actually, for our domain, we go negative infinity to 0. I got to jump over 0 and then go to infinity. Same thing with the range. It's going to be exactly the same thing. Negative infinity, I come up. I don't cross over the asymptote. So I jump over 0 and then go 0 to infinity. Okay, transformation, change in size or position. So if you think about a marching band forming like a V on a football field, we can move ourselves forward 10 yards. We can spread that's going to be a translation. And our translation, we can move up, down, left, or right. A vertical compression makes it wider or slower. Okay, so now instead of it's like slope. It's like a wider slope. And then narrower or faster, vertical stretch. Now my V is coming together tighter. And then a reflection, I flip it over. So we're gonna do these on some different graphs, and we're gonna have a spot for all of these. Our main one here are these two. We're gonna work with these two in today's lesson, but these all work the same. This works for rational. Remember, the parent function of this one was 1 over x. The parent function of this one is x squared. The parent function up here, the ones we're going to work with, the absolute value of x, and the parent function of this one is the square root of x. The biggest thing you need to focus on, pay attention right now, h shows the left or right movement, the opposite of the sign inside the parentheses or inside the absolute value. It is very important that you understand that the negative is part of the formula. So you go h units left or right, h units left or right, k units up or down. So h is going to be my translation, left or right, and you got to watch out for the sign. Okay, and then k will be up or down. And then a, if a is negative, it's reflected over the x-axis. If a is greater than 1, it's going to be a stretch or a vertical stretch. It's going to go up faster. If a is a fraction, then it's going to be a compression, be wider. We'll take a look at some examples. Find the values of h and k to form g of x. So they're saying f of x for all of these are the basic ones. So I think about this, and I think about this going left 2, up 1. So if you're thinking about it, left 2, up 1. If you look at the y equals a times absolute value of x minus h plus k, left 2 means this is going to be negative 2. I'm going to actually have an x minus negative 2. So this one will be g of x equals x plus 2 plus 1. And that's where that minus, this is the biggest thing you got to watch out for. If that's a minus and that's a plus, this means we went left because the value of h is negative 2. X minus negative 2. Watch out for that. This is the square root one, and it looks like we went 1, 2, 3, 1, 2, 3, 4. So we went 3 right, and we went 4 down. So again, I'm going to follow the function up here, x minus h plus k. The value of h is positive 3 because it's right. So I'm just going to go g of x here equals, whoa, that's going to be way too big. I'll be okay. I'll deal with it. Well, let's get rid of that. I got to get rid of that. That's not going to work. Okay, let's get her figured out. So I'm going to go square root of x minus 3. Again, I went right 3. The value of h is positive 3, but the minus is part of the formula. And then I went down 4. Right 3, down 4. So the down 4 is minus 4, just like you would predict. But the left and right is kind of an opposite idea. You need to be careful. Parent function here, y equals x squared. Go 1, 2, 3, 4 left, 1 up. 4 left, 1 up. Think about your parent function for y equals a times x minus h squared plus k. The value of h is negative 4. G of x here would be would be, and none of these have an a going on, so we'll take a look at that in a minute. X minus -4. The minus is part of the formula. Left means negative. Minus -4 is x plus 4 squared. Up 1 is plus 1. This is a cubed, which we didn't have in our, it's fine. I'm taking it 2 to the right. If I'm taking something 2 to the right, then I'm on the x minus h cubed plus k. Even though we didn't have this on one of our parent functions, this is the parent function for the cubed. Well, all of the same rules apply, so it's no big deal. G of x equals, and I'm going right to, so the value of h is positive 2, so it's x minus 2 cubed. There you have it. Match them. Let's see if we can find some stuff here. This looks like it's the blue one is the parent, and I'm reflected over the x-axis. So reflected over the x-axis. That's going to be this one. Let's call this, I don't know, 1, 2, 3, 4, 5, 6. This one's got to be 4. Okay, this one looks like it's 1, 2, 3 left. That would be translated to the left. Translation is when I move it. That's 1. This one looks like it's going up faster or going up steeper. That means it's vertically stretched. Vertically stretched. This whole thing was moved up 2, translated up 2 units. This blue one, and then I go down, I'm actually going slower. It's not going up as fast. Vertical compression is what we call that. It's going to go up slower. And then this one looks like everything was reflected to the left, and that's a little bit different. So this is reflected in the y-axis. Number 5. Describe and write an equation for each function. So again, this one, the parent function would be x squared, and then the translation. So I got to figure out, it looks like I went 4 left, 6 down. So I like to make note of that. 4 left is -4 for h, and 6 down is -6 for k. Y equals x plus 4 squared minus 6. Again, whoa, what happened there? I don't know what happened there. Oh my goodness. Oh my goodness gracious. There we have it. Okay, this is a absolute value. So the parent function is this one, and we would be dealing with my translations here. And it looks like I went 2, 4, 5 right. I'm looking for that vertex of that V, and then these are counting by 2, so you got to watch out. 2 down. 5 right means the value of h is positive 5. So it's x minus, 5, and then down 2. That's a terrible looking 5. Again, you got to watch out. The minus is part of the formula. The value of h is positive, so it just goes in there nicely. Describe the transformation and sketch the graph. Okay, this should be y equals, x minus h. So this is 4 right. It's always going to kind of be the opposite. And then this is -6. This is down 6. So I'm going to go 4 right and down 6. And I'm going to put a point. And that would have moved this one off of it. And then I just kind of think about, where is my parent function? My parent function is the square root of 1 is 1 and the square root of 4 is 2. And I just use these 3 little points. Square root of 1 is 1, 1, 2, 3, 4. Square root of 4 is 2. And boom, I've got the shape. Isn't that great? Isn't that great? Because that whole thing just moved. Here's another one. This is going to be reflected over the x-axis. It's going to be bounced down, because I'm making all of the values negative. Normally I'm up here. Instead I'll go this way. And this is going to go 6 right because of the -6. And it's going to go up 5. Okay. +5 and x minus h. The value of h is +6. 6 right, up 5, find your spot. But now instead of going this way, I'm going to go down. I'm reflected down. And then how do I know where to go? Remember 1, 2, 3, 4, 2 is kind of your jam. And there we go. Whoa, that's a terrible looking drawing. Normally I would have been here, right? But I went right 6, up 5, and then I flipped it over. Love it. Okay, now I got, I'm coming these ones off of y equals the absolute value of x. This one's going to be right 4. 1, 2, 3, 4. Now there's no value of a in front of it. So remember, the absolute value, you think of it as we got a slope of 1 going this direction and a slope of -1 going this direction. Okay. This one is going to be flipped or reflected over the x-axis. So it's going to be instead of a V up, it's a V opening down. Reflected over the x-axis. It's going to be vertically stretched or narrower. And I'm fine if you just describe that. That's called a vertical stretch. Means it's going to go down quicker. And then I'm going to go, this is going to go left 7 because it's x minus -7. The value of h was negative. And this is down 1. And you kind of follow the order of operations here when you put this stuff together. But I'm going to think about 7 to the left and 1 down, and I'm going to put my vertex there. And then I'm going to think about the fact that the V, instead of going up like this one, it's going to go down like this one. And we're going to need a slope of 2 going in both directions, going here. So I'm going kind of down. This is actually like a positive 2. And then I'm going to go the other way, and that's how I compress that guy. Isn't that great? Yeah, this is good stuff. Okay. There we go. I think that's about it. Should have a worksheet. I think there's quite a few practice problems. And again, focus on that h and k. That h is the one that'll get you. Y equals a times x minus h plus k. That minus is part of the solution, so it's kind of an opposite idea.